If f of x is equal to x squared plus 3x plus 2, and g of x is equal to x plus 1, find, in part A, f over g of x. Then we'll go to part B and find f over g of negative 2. Starting with part A, though, this is indicating that we need to divide f of x by g of x. In other words, that's x squared plus 3x plus 2 in the numerator divided by x plus 1 in the denominator. Now, since our divisor is a binomial, to actually perform this division, we need to use long division. So let's go ahead and do this and write x plus 1 divided into x squared plus 3x plus 2. Now, x goes into x squared x times. Multiplying back, we get an x squared plus x. At this step, we need to subtract. I'm going to do that by changing signs and adding, or adding the opposite. Positive x squared and a negative x squared cancels. 3x and a negative x is 2x. Let's drop the 2 and repeat process. X goes into 2x 2 times. Multiplying back, 2 times x is 2x. 2 times 1 is 2. At this step, let's subtract by adding the opposite, changing signs and adding. Here, the x terms cancel and the number terms cancel. This has a 0 remainder. So let's indicate then that f over g of x is equal to x plus 2. Now I'm going to put a restriction on here that x cannot take on the value of negative 1. Now we don't notice that really in this function. However, this restriction comes from our original quotient in which we had a denominator of x plus 1. If we let x equal negative 1, that would cause a 0 denominator. So it's this denominator that causes that restriction. Now let's move on to part B. In part B, we want to find f over g of negative 2. Let's use our result from part A, in which we found that f over g is equal to x plus 2. Therefore, we want to substitute negative 2 into that function for x, which gives negative 2 then in place of x, plus 2, or 0. So for part B, f over g of negative 2 is equal to 0.